In question 1815, we have a 30 volt rated transformer, and we're asked to find the secondary voltage, peak voltage, as well as the average voltages at the load and current. First thing to remember is we have to convert the 30 volts AC or RMS value to a peak value. And the way we do that is we simply multiply the RMS value by the square root of 2. Conversely, of course, you could divide the RMS value by 0.707, which would give you the same answer. So in our case, the voltage in the peak in the secondary, voltage secondary, peak, is going to be equal to 30 volts RMS times the square root of 2, and that equals 42.426 volts peak. Now remember, that's across the entire secondary. This secondary is split into two windings, and therefore the voltage across half of the secondary is going to be half of this voltage. So the voltage across 1/2 of the secondary is 42.426 volts peak divided by 2 is equal to 21.213 volts peak. So that's the voltage between here and the ground, or the peak voltage between here and the ground. Now the voltage at the load is going to be slightly lower by the drop across these two resistors. So the voltage across RL, this will be peak voltage, is going to equal to 21.213 volts peak minus 0.7 volts, and that equals to 20.513 volts peak. Now we have to convert this peak value to an average value. Now remember, for a half-wave rectifier, to get the average value, we simply divide this by pi. But since this is a full-wave bridge, we're going to multiply this number by 2 and then divide it by pi. So the voltage across RL, average, is equal to 2 pi times 20.513 volts peak is equal to 13.059 volts average. Now to find the average current, we simply apply Ohm's law. Current through the load, RL, average, is equal to, applying Ohm's law, 13.059 volts average divided by that resistance, 6.2K, is equal to 2.1063 milliamps.